So we've done quite a lot of modeling together already here, and we've got quite a bit of data entered and flowing through from our Rhino model into our Grasshopper definition and ultimately into our PHPP. So if you've been following along throughout the previous videos, hopefully you have something that looks roughly like what I've got on the screen here with a simple two-zone building mass, some windows, and all of that flowing through in our Grasshopper definition. So that's great. Let's now briefly take a look at our PHPP and see where things stand in terms of how complete our PHPP looks. So I'm going to come over and go to my PHPP document. And so this is the typical PHPP. This is being streamed, or all the information here is streaming out from Grasshopper. Of course, if we come into something like our areas worksheet, we can see all of our different surfaces. We see all of their surface assignments are assessed correctly. We get our surface areas. If we were to come over to the right, we would see that we get all of our construction assemblies. If we were to look at our U-values worksheet, we would see things like double stud wall and pretty good floor, all the U-values flowing through correctly. After the last section, if we were to come into our Windows worksheet, we would see all of our windows being entered here one at a time, with all of their information in terms of glazing and frame types. So we've assigned all of those various parameters and entered all that information here. So that's all great. That all looks like it's working properly. But if we were to come back to the verification worksheet, so the verification worksheet here in our PHPP, what we would see is that we're still not getting any results. So we're not actually getting any answers, right? The purpose of something like a PHPP model is to give us a couple of important data points. How much energy are we consuming for heating? How much energy are we consuming for cooling? What's our likelihood of overheating risk? What's our total primary energy and primary energy renewable demand over the course of a year? And are we or are we not Passive House certification level in terms of performance? We're not getting any of that. Right? We're not getting any answers here whatsoever. Once the PHPP is completed, we would expect to see a bunch of results here. So why isn't this working? What is it that's still missing? Well, there's one really important piece of information which is still missing or has not been entered anywhere in our process so far, and that's this guy right here, the treated floor area. So until we input the net interior floor area of the building, we're not going to get any results. We're not going to see any answers whatsoever. Nothing's going to be able to calculate until that floor area is entered. So let's take a look at how we're going to enter that information. We'll look at a way to estimate that information, and then we will take a look at a much more detailed process for inputting that information. So let me minimize this. Let me go back to my Rhino and Grasshopper scenes here. So I've got my Rhino model on the left and my Grasshopper definition on the right-hand side here. And the easiest way, the simplest way for us to get some net interior floor area information into our PHPP model is to estimate. And so we can do that quite simply by coming over here to my model configuration. So we haven't looked too much at these components. We've mostly been working in our honeybee zones, but for now, let's come over and take a look at our model configuration. And if I zoom in here, remember I've got my honeybee model. So I make my typical honeybee model, and that, whoops, do that. And my honeybee model, I can send that data off to OpenStudio or Radiance or wherever. But I can also take that honeybee model and I can feed it into my LadybugTools adapter, or my PHPP adapter, more properly. So there's a whole bunch of inputs here that we haven't not looked at yet. So let's take a look at one of them right now. And the easiest one, or the first one that we want to look at, is this guy right here, this estimated TFA. Notice that this is a Boolean, so it's a true-false, and it says set this true if you want to have this component try and estimate the TFA based on the gross floor area of your honeybee zones or surfaces. Leave it false or leave it blank, or set it false or leave it blank to not do that. So the easiest way that we can get some TFA information is to just set this to true. So I can take a Boolean toggle and set my estimated TFA to true, and then that's going to update and ripple through my PHPP. And if we were to go back to our PHPP now and take a look, notice that we are now getting a TFA input, 128.8. We're now starting to see a bunch of results here. Obviously, things like PER demand, we haven't set up any heating or cooling system, so we can ignore that one for the time being. But we are starting to see some information here. So we're starting to see some results, and we get our TFA. So that's great. So we can always come in and just say, yeah, estimate the TFA. That's good enough. If we're in maybe schematic design phase, that's perfectly acceptable for those kind of early phase assessments. But 128, is that the right answer? Is that correct? Is that the right number? Well, no, it's just an estimate. It's just an estimate based on the honeybee geometry. So it's not going to be as accurate as we would need for actual PHI certification. So that's fine. We have that tool. I'm going to remove that. I'm going to turn that to false or leave that off. And instead, we're going to turn our attention to a different set of tools that are going to allow us to model the TFA much more explicitly, much more in detail. So okay, so let's sort of leave this alone for now. I'm gonna go ahead and turn my PHPP off for the time being, just to make sure we don't slow anything down here. So I'm gonna turn that off, and let me minimize my grasshopper scene here. So if we want to be really detailed and really careful with our interior floor area input, which we should do. It's a very important parameter in pass-fail certification, one that's often done incorrectly. So it's important to input that information correctly. I think the easiest way to do that is to just draw the floor area. I don't really know a simpler way to do that, other than to just draw it and to enter that information. So what would that look like? Well, for instance, we have our model here, and maybe I would come over here and let me actually turn off my windows, and let me turn off my geometry as well. And let me turn on the CAD plan 01. So I've got my CAD. Remember, I've got my CAD plan loaded up. This was just maybe the design team gave us this, and this is the building that we're modeling. This is our little sample building here. And notice we've got an interior floor layout, got our entry, our open living and kitchen, got our mechanical space, our little den and bathroom closet here as well. So if I want to calculate the net interior floor area of this, I think the easiest way is to just draw those floor areas and then let the geometry drive all those parameters. And then if the floor area changes, you change your surfaces, and all of the parameters get automatically updated in the PHPP. So I'm going to come in here, and I'm going to come into my layers. I'm going to make a new layer. What do we call this? Call this O3 Interiors. And I'm going to make a sublayer called TFA Surfaces. And I'm going to set that as my active layer. So I'm going to make a new layer called O3 Surfaces and TFA Surfaces. And I'm going to go ahead and draw the TFA surfaces as they are shown in our CAD plan here. And so if I was to come up to my surface tools and come to a standard rectangle, I might come in and I might just go snap here and snap there, and go through one at a time and build all of those surfaces one surface at a time. So that would be fine. We could absolutely do that, right? And we will. So let's go through and do that, and let's build all of those individual surfaces. And then we'll look at how we harvest information like total surface area out of those elements there. And as we talked about before, normally I would not recommend snapping directly to the CAD plan. Normally for something, I would say, well, you should do something like this, and then you should use your scale tool to sort of reconfigure that, make sure that that's an actual rectangle. In this case, I've gone through everything that's very clean in terms of the geometry, so we can safely snap to all of our different our vertices here without too much worry. So I'm just going to come through and I'm going to draw out these zones. You can use whatever, that's wrong. You can use whatever geometry creation tools you like in Rhino. That's totally fine. When we have a surface like this, we want to join this into a single surface. So we say join, and then we would say like merge all faces or merge faces to. Oops, what is? Oh, right, it's different now. Sorry, I'm used to old Rhino. I've only just updated to Rhino 7 recently. Anyway, we will, right, Planar Union. That's what we have to use now. We used to be able to use merge faces. Now we use Planar Union. All right, fine. That's what it was. Okay, so anyway, we can merge those together into a single surface. And let's do our kitchen now. So let's say kitchen. We'll draw from here to here. And we'll draw... Let's draw this. Remember, for TFA, of course, we want the net interior floor area. So we want to exclude all of those wall thicknesses for purposes of calculating this. So let me come through and grab those guys and grab this. And again, do our planar union, join and planar union there. And do our closet. And then we'll do our last couple bits here. We'll do our washroom and then our den, and then we'll take a look at the main living space there, the open space. So we've got this open living room, and then we've got this open stairway over here. So let's go ahead and do this. So I'll do this kind of little entryway bit here, and then do this. Well, that's not really right because we've got the stair there. So we could cut that out in a couple of different ways. Do it this way. Just for, I'll do this, and I'll do planar union again to join all of those things together. And this isn't a wall, this is a sort of open to above, so actually that should be part of the, I guess that should be part of the kitchen, I suppose, that guy there. So do that planar union again, and there we go. So we've got our living room, our kitchen, our den, our bathroom, our closet, mechanical room, another closet, and an entry. And I've drawn them all on this TFA surfaces. So that's great. Okay, so we've got a bunch of surfaces now. If I right click and say select those objects, how can I bring those into my grasshopper scene? Well, it's pretty straightforward. I'll come back over here to my create honeybee rooms. We're on the first floor. So if I was to come in here and say brep and say set multiple breps, and I'll call these my TFA surfaces. Go. Now, how can I get the area information? Well, certainly I can use native Grasshopper tools to give me the area, right? So I can get the area of all of the different individual elements. And of course, the nice thing about that is that if I come in here and I, adjust one of these, the area adjusts accordingly, right? So it's sort of live information, as it were. And if we want the total, we could say like mass addition and add all those stuff together. And there we go. There's our total TFA for the ground floor, 62 square meters. So that's fine. How, though, are we going to intelligently pass this information along? Really, what I'd like to do is I would like to sort of associate this information with this zone, with this first floor honeybee room. And so I can do that. I can sort of add this information to this room so that wherever this room goes, this information will travel along with it. And I can do that relatively straightforwardly using one of our new Passivhaus tools components. So rather than sort of calculating all of this stuff ourselves, instead, what we're going to do is we're going to come up to the Passivhaus Tools toolbar. I'm going to come over to the O1 model. And now I'm going to come down to, so we've been looking at this top section so far. We've been looking at the window tools. Now I'm going to come down to the second section here, and I'm going to come to this guy that's labeled Ladybug to PH Tools, Create PHPP Spaces. So we want to create some PHP spaces, and this tool is going to automate a lot of this calculation. It's also going to sort of embed a lot of this data in the honeybee room. So if I add this create PHP spaces to the canvas here, notice we get a new component. And let's take a look at what this is going to take as input. So first of all, it's going to take in a set of TFA surfaces. So one or more individual TFA surfaces. So we've just drawn a whole bunch of TFA surfaces. Looks like we can input those right here into this component. We also have the option to input some space geometry. We'll come back and talk about that later. As well as it looks like we've got some ventilation information. Again, we'll come back and talk about that at a later date. We also have the honeybee rooms input, and then something called set honeybee loads. That has to do with the ventilation. So, okay, so we've got a whole bunch of inputs. It looks like we only need to set a couple of them to sort of get this working. So first of all, I'm in my first floor. I have a first floor honeybee room, right? All this is just a honeybee room, first floor. So if I pass that to this new room PHP spaces component, notice that that's going to flow into my honeybee rooms correctly, and so far so good. Let me delete this stuff. In order for this to work, the other thing that we need is some TFA surface geometry. So I can take my TFA surface geometry, and I can input that into the TFA surfaces. So go off and think for a minute, and when it's done, let me preview this. When it's done, we'll get some information as a result. So first of all, we get honeybee rooms. So there's our first floor honeybee room. But importantly, this room has been modified, and we've added a bunch of new information to it. In particular, we've added this new PHP spaces, or these new PHP spaces. In this case, we have a single space object, and it's made up of a bunch of individual breps and a bunch of information. So if we want to see what has been done here, we can connect the space brep to a typical brep tool, and let's come over here and take a look. What has happened? Well, this tool, this component, has interpreted all of our inputs, and it has created a bunch of interior spaces based on that input. All of these spaces, all of their parameters in terms of their floor area, as well as their volume, their room numbers and names, etc., all of that is getting embedded inside of the honeybee room. So a bunch of new information has just been added to the honeybee room. And in order for us to then pass that along to the sort of next link in the chain, all we need to do is take my honeybee room's output and then pass that along. And now that's going to flow along into the rest of our tool. So let me give ourselves a little more space here so that we keep things nice and tidy. And there we go. So we now have a new spaces tool, which is creating a bunch of spaces, adding them to our honeybee room, and then sending that along the sort of chain here. So we've got a whole bunch of new information flowing through. So when we come back in the next section, so that's one simple way to just add some of that TFA information. So we can either use the estimator or we can use this PHP spaces. But when we come back, we will talk about how we can encode a whole bunch more information here. Things like room names and room numbers, TFA factors, reduction factors, how are we going to deal with the stair area here, all of that stuff, as well as some other bits and pieces. So when we come back, we'll take a look at this in a lot more detail, as well as several of the different options here for how to configure this to our liking.